Good day, ladies and gentlemen, boys and girls, friends and neighbors. So in this brief little video, we're going to look at some linear equations in standard form. And more importantly, we're going to use the x and y intercepts of these linear equations to graph these linear equations. So a linear equation in standard form is going to look like this. It's going to have a number times x plus a number times y is equal to a number. And it's very important to note that here, the x and y's, we're going to let those are variables. And these a, B, and C, these are what we're going to call the constants of the equation. And you'll see what this means pretty quick. What we need to understand is that a linear equation, the graph of a linear equation, is a line. And we're going to do a lot in the next week or so about graphs of lines. Well, we're going to do a lot in the next couple years about the graph of lines. In one way you can put the graph of a line is in standard form. So we're just going to look at some standard forms. We're going to look at the x and y intercepts of a line in standard form and then graph those lines. So what we're going to do first about this is we're going to understand what the heck an x and y intercept is. And we're going to have to realize here that we are always, everything that we graph, for a while anyway, is going to be graphed in the xy coordinate axes. And you certainly are familiar with the xy coordinate axes, where the horizontal is the x-axis and this vertical line is the y-axis. What we're going to call an x-intercept, or what an x-intercept is, it's going to be any point that's on the x-axis where the graph, an x-intercept of the graph, is a point where the graph crosses the x-axis. In like manner, where the graph of anything crosses the y-axis, that's what we're going to call the y-intercept. Lines will only have one x-intercept and one y-intercept. So that's going to be important to note, because the first creatures that we're going to graph are going to be lines. So, and it's important to note that x-intercepts, and if I look again at these points here, what do I know about all those points? Well, all of those points have a y-coordinate of 0. And all of these points are going to be some number, comma 0. And keep in mind, it could be 0, 0 as a y-intercept. Or an x-intercept, excuse me. So, but all x-intercepts have this y-coordinate that is 0. And we know about an ordered pair, x comma y. All ordered pairs are x comma y, where the x comes first. So x-intercepts, the y here is going to be 0. They all are. In like manner, y-intercepts all have an x-coordinate of 0. Again, if I look at all of these points here on the y-axis, they're all going to have an x-coordinate of 0. And they're going to look like 0, comma b. And again, a linear equation will only have one x-intercept and one y-intercept. So we're going to use these two facts, that an x-intercept has a y-coordinate of 0 and a y-intercept has an x-coordinate of 0, to find some x-intercepts and graph some linear equations written in standard form. So here's our first example. Our first example, I have already graphed this line. And again, here you go. Here is a line in standard form. I have a number x plus a number y is equal to a number. This happens to be the graph of this line right here. And it appears that this line is going to intersect the y at this point 0, 2. It appears that 0, 2 is the y-intercept of this particular linear equation. So let's check to see if 0, 2 is indeed on this equation. So if I write the equation over here, what I'm going to do is just rewrite the equation. 2x plus 3y is equal to 6. And I'm going to put this point 0, 2 in. I'm going to put this x comma y, which is 0, 2, into this equation and see if it is indeed true. If the equation is true, then I know that that is indeed the y-intercept. So I'm going to put 0 in for x. So I have 2 times 0 plus 3 times 2. Does that equal 6? Well, by golly, it does, because 2 times 0 is 0. 3 times 2 is 6. So I do indeed have 6 equals 6. So this is the y-intercept of this line here. In like manner, it appears that this rascal here, this point here, it appears that that point is 3, 0. If it is, then 3, 0 is the x-intercept of this. And what are we going to do? We're going to put that 3, 0 into that equation and see if it makes the equation true. If it is, then we know we have found the x-intercept. So let's put that rascal in here. I'm going to put 3 in for x. So I have 2 times 3 plus 3 times 0. Does that indeed equal 6? Well, 2 times 3 does equal 6. So 6 does equal 6. So that's a check, okay. So this is indeed the x-intercept of this linear equation. Let's write the x where we can see it. And this is indeed the y-intercept of this linear equation. So that's what this video is all about. It's linear equations in standard form and finding the x and y intercepts to help us graph these linear equations. All right, let's go to another example. And if you need to pause the video to take notes, please do so. So here we go. So we're going to find the x and y intercepts, and we're going to use them to graph the equation. So here is another linear equation in standard form. So this is linear equation in standard form. And down the road, we're going to find lots of other ways to graph linear equations. And what I'm going to do, I'm going to use the fact that x-intercepts have a y-coordinate of 0, and that y-intercepts have an x-coordinate of 0. So the first thing I'm going to do is I'm going to find the y-intercept by I'm going to let x equal 0. And when you do these problems, I would strongly suggest that you write this step out so you know what you're doing. So then I know what you're doing. Hey, you're finding the y-intercept by letting x equal 0. If I let x equal 0 in this equation, what do I get? Oh, well, this guy here is going to be gone because negative 2 times 0 is 0. So I just have this equation 7y is 14. That says y is 2. And this is the x-intercept. This guy right here, pardon me, it's the y-intercept. That's what I was finding. This is the y-intercept of this linear equation, 0, 2. Okay, now I'm going to find the x-intercept. And how am I going to find the x-intercept? I'm going to let the y equal 0. So let's erase this rascal. And what are we going to do? We're going to let y equal 0. 7 times 0 is 0. So what equation will I have? I'm going to have this equation here. This negative 2x is equal to 14. That tells me that x is equal to negative 7. And then that tells me, since the y coordinate is 0, is that this is the x-intercept. So I'm going to plot those 2 points, and I'm going to realize that I am looking at the graph, or I'm looking at the linear standard form of a linear equation that's going to be a line. So when I plot these 2 points, all I need to do then is connect those 2 points with a line. So let's do that. I wonder where I have that. I think I have it on this next slide here. I do. That was my first example. I apologize. So here we go. So here is this line, the line I was talking about, negative 2x plus 7y is 14. And on the previous slide, we did indeed find that the y-intercept was 0, 2, and the x-intercept was negative 7, 0. I'm going to plot those 2 points. Here I go. I'm going to plot the point 0, 2. I'm going to plot the point negative 7, 0. Draw a line, sketch a line through those 2 points, and this red line is indeed, ladies and gentlemen, the graph of that linear equation given in standard form. Before we end the video, let's do one more example. So here we go. Here, note that I do have a linear equation in standard form. This is indeed a linear equation in standard form, because I have the ax plus the by is equal to c. So this is in standard form, and we're going to look at lots of different forms of a line. So what I want to do is I want to find the x and y intercept. I want to find the x-intercept, and I'm going to find the y-intercept. I'm going to plot those points, connect those points with a line to give me the graph of this linear equation. So let's find the x-intercept first. I'm going to write out what I'm going to do. I'm going to find the x-intercept. And how I'm going to find that, I'm going to let y equals... Whoa. A lot of people are saying, well, why do I have to write that? I know what I'm doing. You have to write that because down the road, we're going to graph quadratics. We're going to graph exponentials. We're going to graph multiple polynomial functions. And it's not going to be so obvious what the x and y intercepts are. So I really want you to get used to writing these steps out so that when we get to more complicated equations in x and y, polynomial equations, quadratic equations, you'll know the steps necessary. So that's why it is very important at this stage in the game to write this step down. I'm going to find the x-intercept. I'm going to let y equal 0. And now I'm simply going to, this part here is going to 0 out. What do I have? I have 3x is equal to 12. That says x is equal to 4. And therefore, the x-intercept is going to be 4, 0. And we want to write x and y intercepts as points. You just don't want to go, a lot of people just say 4. You can't just say 4. It's 4, 0. Okay? And so let's now find the y-intercept. And how am I going to find the y-intercept? I'm going to let x equal 0. And I can easily, so this is an important line again. I'm not going to reiterate why that's important. You know it's important. But if I let x equal 0, then I automatically, I can see that, oh, negative 5y is equal to 12, and y is equal to negative 12 fifths. That's going to be a little bit over negative 2. So it's going to be between negative 2 and negative 3. In fact, sorry. In fact, that's going to be negative 2.4. Okay, so what's the y-intercept? The y-intercept, and I'm going to write the y-intercept as I like the fractions more than decimals, so the y-intercept is going to be 0, comma, negative 12 fifths. Okay, so what we're going to do is we're going to graph these 2 points. We're going to sketch a coordinate axis here. Let's go here, make sure that we're in black for the lines, the coordinate axes, and we are. I'm going to graph this x-intercept of 4, 0. Just going to kind of estimate 1, 2, 3, 4. I'm going to graph that. 1, 2, 3, 4. I think a grid of 4 by 4 by 4 grid is going to work for this particular line. We may have to scale, another problems, we may have to scale the x and y a little bit different, and if we do, we'll show you how to do that down the road. So this is the x-intercept. Let's plot that in a different color. Let's plot that purple, sorry. Okay, and then, hey, what's this y-intercept? Is negative 12 fifths, which we said was at 2.4. So here's this point. Now what am I going to do? All I'm going to do is sketch a line through those rascals, and let's do purple this line for this line. I think my line didn't come on. There you go. That's a little bit better. But what is that? That is that's the graph of this particular equation, which is 3x, sorry, 3x minus 5y is equal to 12. This is the graph of that equation. Let's get that little rascal out of there because he's bothering us there. Okay, so let's zoom out and look at that and make sure that we see exactly what we're doing. We're going to look at this as the entire page. There we go. So what I did with this guy here, same thing I did on the previous examples, I found the x-intercept by letting y equal 0. I found the y-intercept by letting x equal 0. I plotted those points and connected the dots. Okay, so graphing linear equations in standard form by finding x and y intercepts is a fairly straightforward topic. So I will see you soon.